Good afternoon, everyone. Thanks for coming. It's my pleasure to speak with you today. A little bit about myself. I'm originally from Los Alamos, New Mexico. My father was an electronics engineer for the Los Alamos National Laboratory, and it was a fascinating place to grow up, and gave me a lifelong interest in computers and technology and electronics. It was quite the experience. So I'd like to talk to you today about the mission of the XPub department, which has a rather broad mandate to modernize the technologies and the work processes used to publish our daily work. So that includes all the congressional bills, resolutions, and amendments. It includes our daily publications, such as the Congressional Record and the Federal Register, and all of the other routine documents that we publish. And MarkLogic is one of the foundational technologies that we're using to accomplish this work. So I'll be talking about how MarkLogic is helping us to meet these objectives. The GPO was founded in 1861. It's been on North Capitol Street ever since. The mission of the GPO is to publish the official documents of Congress and of congressional agencies. We also publish passports. We do not print money. Everyone asks me, do we print money? No, that's the Bureau of Printing and Engraving. We don't print money. Between 1903 and 1940, the original wood frame buildings were replaced, and we got this beautiful modern steel and brick building and 33 acres of floor space. It's a manufacturing facility. You walk through this place, and we have just enormous printing presses and bindery equipment. And I mean, back in the day, they made their own ink, they made their own paper, they delivered the work products using a horse and a carriage, and it's just, you walk through the place and there's still relics of these days, and the history is just fascinating. It's a beautiful building, and I always love just walking around. Lots of great pictures in the hallways. So from the beginning, the GPO would receive manuscript copy from Congress, either legislation or proposed rulemaking, and it was the GPO's job to faithfully print that material. The GPO is not a publisher. We don't write the laws. We don't get to edit what Congress is doing, right? So we have to faithfully reproduce what we're given. The language of bills has to be printed exactly as they were drafted. We do edit some publications for editorial style, documents like the daily documents like the Record and the Register, or congressional hearings and reports. But in all cases, we're working directly from manuscript, right? We don't have editorial license to change things arbitrarily. It's critically important that we accurately print what we're given. Now, when the GPO was founded, printing meant picking letters one at a time out of a box, assembling them in a stick that you held in your hand to typeset one line of type. And then you arrange these lines of type into a metal box called a galley. And then you inked the surface of the letters, and you pressed a piece of paper over the top using a galley press, and that's how things were printed. And you can see that if you're working in this way, there's an obvious separation between whatever editorial processes you're going through and the typesetting process. I mean, these are completely distinct things. And then once you have something that you can print, you've printed that first page, then you proofread it against your original manuscript for accuracy. Someone put in a letter upside down or picked the wrong one out of the box, you gotta fix it, right? So there's no WYSIWYG terminal to help you out. And that kind of that workflow, that division between any editorial actions and typography remains to this day, right? It's an important aspect of how we go about our work. Now, the next major technological change was the invention of the linotype machine. And this incredible contraption, mechanical device, would allow a keyboard operator to cast a line of type using a keyboard and molten lead. And these lines of type were assembled again into a galley and printed. But this is much more efficient than picking out letters one at a time. And the GPO at the time had the largest collection of linotype machines in the world. And we had more than 8,000 employees working in that building downtown, many of them doing precisely this kind of work. And rather than the simple letter presses of the day, the presses got bigger as well. So you could have multiple galleys arranged together and then print a really big piece of paper and fold it and trim it and stitch it together to create bound books. With the invention of photolithography, technological pace of things picked up very quickly, and the GPO had a successive series of photocomposition machines. And the way this worked was you use a photographic process where oftentimes like a plastic wheel is in a mechanism where it rotates almost like an old daisy wheel printer, but it's a photographic process that projects that letter onto a photosensitive negative. And in this way, you're able to set type using a photographic process, and then the resulting negatives were contact printed on a plate, a photosensitive plate, which was then etched and installed on a printing press. And this was tremendously more efficient, than working in molten lead, of course. And later generations of photocomposition machines had CRT screens and keyboards, and this made it possible to correct a mistake as you worked. Now, I started out my career in journalism. Actually, I've got a BA in mass communication from Idaho State, and I was always on the college newspaper. And when I first started, we went down to a local newspaper that had machines very similar to this, and I learned to typeset text using a photocomposition machine, and then an image setter output negatives, and we stripped those onto plates, and that's how the newspaper was printed. And you could say that the combination of keyboard symbols and text that you would type on one of these keyboards is the early precursor of the markup languages we use today, like SGML and HTML and XML and all the rest, because you were entering a combination of symbolic codes and text on a keyboard that would result in text being formatted a specific way. And semantics in XML form, we represent that through the graphic art of typography. So they are very similar in that respect. They're conveying information about the text just visually, not in an electronically readable form. Then in the late 1970s, a number of things happened. The PostScript language was invented, and this made it possible to typeset not just individual columns of text, but an entire page or entire document at a time. And the GPO developed our own internal proprietary composition software called MicroComp that took inspiration from the photocomposition keyboard codes and commands. And they developed a 7-bit ASCII format that was used to typeset document-length documents. And it was originally written for a computer called the Microvax mini computer. And then that was ported to the PC. And even today, documents that originate in XML form, such as congressional bills, are then converted to microcomp locator format. And indeed, all the documents we publish today are typeset using microcomp and its 7-bit ASCII format, which we call locator codes. And I'll briefly walk you through the way this works. Here you see a representation of locator code and a bill that's been typeset using this system. I've had the opportunity to read the original design documentation from the period, and they referred to this format as a full text database. And they had this idea that if these typographic codes were applied consistently, you could begin to describe document semantics. And so this is late 1970s, and they're talking about semantic markup. And they really intended that this format could be used in much the way that HTML was used later. Now here we see a larger representation of it. The rectangular characters to the left, that's the ASCII bell character, ASCII character 7. So all the characters in the ASCII character set below 32, so from bit 0 all the way up to 31, are control characters, and they originally operated teletype machines. You know, if you've seen the movies, you see the ka-chunk, ka-chunk, ka-chunk is someone's reading out a newspaper and news story, and it's being printed around the country on typewriters. Those are teletypes. So ASCII character 7 is a control character. Now if we follow that with a capital F and a 4-digit integer, that says use format file, say 6652. And file 6652 has column definitions and page sizes and typographic format definitions for 99 paragraph styles. So we reference in the format we're going to use. And then you see codes like a bell I and a 2-digit integer. Well, that refers to a paragraph format. So bell I30 means use paragraph definition, style definition 30 in file 6652. And then you see a bell T5. That means use font 5 as referenced by file 6652. So that would make something bold or italics. It overrides the paragraph level formatting. And you'll see a bell K, and that means, okay, cancel the override, go back to using the paragraph definitions. There are many, many more of these locator codes. And using them, you can typeset multi-column, beautifully typeset documents, very complex tables, legal citations, footnotes. It exceeds even today the capabilities of common desktop applications used for desktop publishing. And the other thing about this format is that people get very efficient at working this way. They've got a text editor. They don't have to worry about what the content looks like. They've memorized these codes. They have codes mapped to keyboard shortcuts. And they're very quickly able to mark up copy this way. It's also a flat file, right? There is no hierarchy here. You can arbitrarily break this file up into as many pieces as you like, which means many people can be working on the same file at the same time. And we have a file-based system where work flows from one shared directory to another to support the editorial process. So, you know, my mission is to replace this with a system where we can author content natively in XML, semantically tagged rich XML. And then, through XSLT transforms, we can output that to responsive HTML or to XML itself. We can also print it. We can make PDFs, multi-channel publishing. So an XML native system end-to-end for producing this work. But not so fast, because there's a few requirements that are sticklers here. People care passionately about the look of federal documents. A bill should look like a bill. It carries the weight of the United States government, and it has looked the same practically since the founding of the GPO. Microcomp was designed to look like, produce documents that looked like they were set in cast lead. So, of course, XPub has to produce documents that look like they were published through Microcomp, which was designed to look like documents that were typeset using cast lead type. So there's that. We have to, there's a huge historical preservation aspect of this project. We've got to preserve the look of these documents. And then there's a question of scale. So you might chuckle looking at the locator format, but then realize we get content for, say, the Congressional Record all day long. We have employees working around the clock on 3 shifts. If Congress is in session late, they might not adjourn until 8 o'clock at night. So we're getting our last content then. That's all got to be proofread and typeset and corrected and turned into a book. might be longer than 1,000 pages. And oh, by the way, we have to print and deliver the thing by 8 o'clock in the morning, and then we put it online as well. So we've got to scale it. And that's not an easy thing to do. In my prior career as a technical writer, I did a lot of work in DITA, I did a lot of work in XML, and I can tell you, if you have, pick your XML editor of choice and you load in a schema, and if you're writing a mil-spec document, life is great because it's prompting you. Essentially, creating a document based on a mil-spec is like filling out a form. I used to work in aerospace. But if you paste in a partially structured Word file directly into that editor, you're going to spend several days fighting with it because it's completely invalid against the schema, and it is an absolute bear to fix. What I would often do in that situation is I would just insert the structure and copy and paste in the text. It was about the most efficient way I could work. Well, that's not going to cut it when we've got thousands of pages of content to publish. We don't dare make a mistake. You don't want to forget a paragraph. You don't want to actually delete something. You don't want to put it in twice. So that kind of a workflow just simply doesn't scale. And that's the big problem we're trying to solve. So in attempting to solve this problem, what we're building is an enterprise 3-tiered application. Now we've got a data tier, that's where MarkLogic lives. And we've got a middle tier, and these are web-based REST services that we can mix and match as needed to fulfill various requirements. And then we have a presentation tier, and that's where the clients live. So those are multiple web-based clients or desktop applications or external APIs that all have access to the middle tier and can be used to produce documents using XPub. So there's MarkLogic in the data tier. That's where all the content is going to reside. So today, content arrives from Congress and from federal agencies. It's FTP'd and it lands in a whole bunch of different network shares. And each network share is for a specific type of document. We've got VEX, VMS scripts, and other kinds of scripts that propagate these files throughout the network. So what will happen is all that content will arrive and immediately get loaded into MarkLogic. So that's going to replace the alpha servers. It's going to replace all the VEX, VMS scripts. It's going to replace all of that infrastructure. MarkLogic will be the place where the content is, all the editorial actions take place. The content is marked up, it's proofread, and it's published in multiple forms. MarkLogic isn't going to be the place where the content is published and distributed. That is carried out by, that's all done on govinfo.gov, which is our publicly facing location for all the documents we make available to the public. And the reason for that is the GPO walks a very narrow line. You can have an honest debate about how much an agency should do and how much the private sector should do. So our position, our carefully crafted position, has been that we will make content available in semantically rich XML because that is of a public benefit. And we'll make this information searchable and available on a publicly facing website, govinfo, and we'll make it available for bulk download so it can be consumed. But we're not going to do anything like adding extensive ontologies and metadata to it, and we're not going to build really sophisticated search and retrieval and to that system because that would be competing with the private sector. So as more and more documents get moved into XML, then there's more and more opportunities for businesses to monetize that content. My team published the January 6th committee report, and I was working directly with the committee. They were writing in Word. We were receiving their content. We're typesetting it. Incredibly, the January 6th report was available for sale on Amazon. Well, and you could buy lots of versions of the January 6th report actually on Amazon, and that's because all these different news organizations and other parties scraped the content and published it, and that's what they intended to do, and that's what we allow them to do. We want them to do that. And then they all add their own forward to it and their own interpretations and analysis, and that's the way things should be. So we're not using all of the capabilities the one might think we would use out of MarkLogic, right? We're using it for content creation, and we're also holding on to content. So the Congressional record gets republished annually as the bound record. Public laws get republished as the statutes at large. So there are, for documents that are republished annually as volumes, we would retain the source, then we would use MarkLogic to combine it and republish it annually. But we're strictly using it to drive our editorial operations, our publishing operations. And that's so that we can fulfill our mission and not stray past our mission. Now the next piece of foundational technology is XPP, or XML Professional Publisher. This is the one-for-one replacement with Microcomp. It's a server-based, multi-million-dollar print composition system. We published the 2018 main edition of the U.S. Code. It was authored still then in locator format. Wrote software to convert it to XML, and we loaded it into XPP. And because XPP is programmable, it can auto-calculate footnotes and complex legal citations and section numbers. And just by doing that, we shaved 1.5 years off the production schedule. And then we published all the supplements since, and this coming year, we'll republish the main edition, and by that time, the entire U.S. Code will be moved over to USLM XML, and we'll publish it natively in XML. So we work very closely with the Law Revision Council on that publication. We also use ABBY Fine Reader. It's an enterprise program for optical character recognition. The neat thing about it is it gives you XML back. It gives you a confidence factor for each character. And so we'll use that on the front end in the editor we're building, so that if it thinks it spelled a word wrong, we might as well highlight it for the user to correct, rather than just blindly convert it to text and have no idea what's right and what's wrong. Because even the best OCR program is, highly error prone, and we receive content in every form you can imagine, including, 1-inch high manuscript that we have to OCR scan and correct. And we still have to get it done in, overnight. Now we have the middle tier. We've got multi-layered role-based security, and so we've got REST services devoted to security. We have the network monitoring service. I alluded to that earlier. It can be configured to watch various network shares, and then the content it finds gets loaded into the appropriate MarkLogic collections. We've got a workflow management service, so that will replace the VAX VMS scripts and the other multiple shared directories that are used to propagate work throughout the organization today. We'll have a workflow component integrated with MarkLogic for managing editorial workflows. We have the content management service. So we're choosing to abstract MarkLogic with a REST service. And the reason why we're doing that is because we don't want to put all of the logic for a content management system in the clients. We want to be able to support multiple clients. We want to use dedicated collections for different customers. I mean, if a congressional committee is going to store their work someplace, they need to know it's secure. Other people can't get to it. So our security posture involves, this level of indirection. The great thing about MarkLogic, it supports a REST API, and that's what we're using to build the system. So you'll see that for all these back-end server-side components, we abstract them all into the middle tier as individual REST services. We have the document processing service, and this is a clever thing. What this does is, we don't want to write C# code for every new document we have to create. What we want to be able to do is mix and match XSLT transforms and various REST services as needed to produce the desired output. We want to be able to add new documents at any time we choose. So what this thing does is it receives whatever your source file is, and then it receives what we're calling a recipe. And a recipe is an XML file that describes a series of REST API calls and their arguments. And this way we could write a simple XML file to direct the XPub system to perform a series of operations that processes a file in any number of ways. Then we have a series of supporting REST services. These are all intended to be called by the document processing service. So we've got the print composition service. It abstracts XPP. So XPP also has a REST API. Print composition service, you send it an XML file. We've developed our own schema for communicating with XPP. We call it our typesetting XML standard. And so whatever we're going to print, we turn into typesetting XML. We give that to the print composition service along with the name of the style set that it's to use, and then XPP could render that to PDF, and then it gives that back to the print composition service, which then gives it back to the calling application. We have the XSLT transformation service. It abstracts the Saxon XSLT processor. We're using the Saxon version 3.0 of the XSLT language. All of the logic that determines how semantic XML should be rendered through the art of typography resides in XSLT transforms. So we're a big believer in clean separation of concerns. The beauty of XSLT code is it's testable. And then the only logic that we put in XPP itself is logic that's page dependent. So if you're going to have a footnote or a footnote index, or a table of contents that's referencing page numbers or section numbers or things of this sort, you don't know what those are until you actually compose the pages. So page-dependent logic resides in XPP. Everything else related to the association of XML semantics to typography lives within the XSLT transforms. Then we have services devoted to converting Word and Excel files to XML. We've developed our own schema called Intermediate XML. These services extract the graphics. They provide options for dealing with track changes. You either accept them all or you use the latest approved version. And so we often have to deal with Word files and Excel files, and this provides a mechanism of converting these files reliably to XML. If we're really, really lucky, and a user used named paragraph styles in Word and named inline formatting styles in Word, we preserve that. If, as is the likely case, everything is styled as normal and they overrode the styles using the formatting ribbon, we capture the formats that they chose to use so that through heuristics we can make some logical determinations of intent. We also have a PDF augmentation service. This gives us the ability to attach files to PDFs and also augment PDF metadata, so that gets its own service. And we have the OCR conversion service that abstracts EVI Fine Reader. So everything on the data tier is abstracted with the middle tier service. Now we have our clients in the presentation tier. The first is XPub Horseshoe. And it's got a silly name, but it refers to the horseshoe-shaped desk where people pick up their work today. So we wanted to tie that back to something that people would recognize and be familiar with. And this is a Windows WPF thick client application that we're building from the ground up to hopefully make it practical to mark up XML at scale. And this is probably one of the biggest technical challenges on the project, honestly. And then it will consume the workflow management service, the content management service, and the document processing service to do all of its operations. Get files from MarkLogic, send them back, submit work, receive work, all of those kind of editorial processes would, the middle tier would be handling all that work on the back end. We also have something we're calling XPub Direct. This is a set of externally facing websites that House and Senate committees will be able to use to create hearings and reports from Word files. And if they follow a prescribed template, they would be able to basically self-publish this themselves. Otherwise, they can get a preview of their files and pick from an a la carte menu of services from the GPO, and we'll do whatever additional work they request. And we've got something we're calling XPub Connect, and that is a externally facing API that exposes the document processing service. And so agencies that have their own XML authoring tools, like the Large Vision Council, they can integrate their authoring environment with XPub through this API. We're already using this so that the LRC can generate previews of the US code using this API. Of course, it's secure in many, many ways, but that's nice and successfully working. Just a quick illustration of how this document processing service works. So, network monitoring service finds a file in a network share. It knows what kind of file it is because where it landed. So say it's a Word file. It knows what recipe to use for a file landing in that directory. And then that recipe causes the document processing service to convert the Word file to XML and then run 2 different XSLT transforms, load the result in MarkLogic, and then initiate a workflow process. And so we're able to do all of that just by simply writing an XML file that calls these services. Services are all designed to accept multi-part data for both the request and the response, and they're designed to all be interoperable, and they're designed to all operate under the guidance or direction of the document processing service. So we think this is kind of a clever thing. We've got this working. Here's another recipe. So imagine you're working in the Horseshoe client. You want to make a PDF of the file you have open to see what it looks like. You might pull the file out of the content management service, so it's coming out of MarkLogic. You run a transform to produce typesetting XML for XBP. It's then routed to the print composition service. It goes to XBP. It gets composed. PDF file is returned. And so in this way, we're able to mix and match transforms, mix and match REST services, without incurring the need to write a whole bunch of code to add new documents or, support new requirements. I want to talk a little bit more about the role of MarkLogic in the system we're building. So, MarkLogic's going to replace a lot of infrastructure. I've mentioned these VAX systems. It's becoming very hard to maintain them and just even get spare parts. There's a lot of various scripts that were written over the years to implement editorial workflows. So all of that, lands in MarkLogic. I mentioned these locator files can be broken apart arbitrarily. Well, with MarkLogic, we can extract a section level XML component from a larger document, have it edited, go through multiple editorial and approval cycles, put it back where it belongs. So that, that's another role that MarkLogic is playing is, XPath-based searches and retrievals and updates on content. We're also going to use MarkLogic to store before and after versions of XML files. Basically, we envision our employees as they're going about their work, it seems reasonable that they would be training an AI system that could at least assist with the tagging. So we're hoping eventually, once this is in production for maybe a year or two, to go back and see if we could build models and train them to kind of offer some assistive tagging features, sort of like the way Visual Studio works, if you've ever used it, where it offers, it tries to do code completions. It'll insert, simple structures. If you're going to write a case statement, it puts in the boilerplate that you need, that sort of thing. We went through a lot of analysis before settling on MarkLogic. The first thing we do is, we got a trial license, and we just started loading hundreds of thousands of pages of content. And then we started retrieving them, and, it handled that without a problem. So that was obviously, a plus in that in MarkLogic's column there. And then we also had our IT department analyze it for federal IT security compliance. And it works well on a federal network. It's not doing anything that would give our security people pause. And so, luckily we were able to procure it. We have MarkLogic running in 2 different data centers, and we're building this solution on top of it. And as we accomplish more and more work, then we'll expand the MarkLogic infrastructure as needed. I mentioned Horseshoe and trying to solve our XML markup problem. This is a drawing, a visual representation of what I have in mind. Now I've got limited skills in Visio. Hopefully something, looking for something looks better than this, but we're looking for a content view that allows users to see the XML structure, but focus on reading and correcting the text. And then a structure view of XML that expands structure from the left and attributes to the right that allows for structural XML editing. And then we'll use Saxon to parse the schema so that we can, show only those elements that are valid at any location in the structure, so we can give the users an interactive pick list of what elements they can apply at any location. And then we envision users being able to pick from a menu of what we're calling macros, but are really exasol view transforms, where they can perform common editorial operations on, say, a document or a table. For example, there's a rule that says, what is it? If you got a table full of dollars, financial figures, the first entry gets the $sign, and all the ones that follow do not. That's just a GPO style rule. Well, today people go through and they delete those $signs one at a time in a text editor. So run a transform on the table, take out all the $signs, that sort of thing. What's that? Alrighty. Well, that's really all I had to show. On the right side, we envision a live CSS preview. So as you work, you'll see what the document would look like. You can also look at a pure XML view. You can look at the original source file. We also intend to develop embedded documentation or work instructions, so that as an employee, if they haven't worked on that kind of document before, the online help is always available. All of our work processes will be embedded in the software, also available online and in printed form, of course, all authored in Data XML. And that's about all I had today. I'm happy to answer any questions anyone has about what we've been up to.
Like last time, if anybody has questions, just repeat them.
Repeat the question, okay.
Any questions?
All right, no? Yes.
I think you mentioned multiple people working on a document at the same time.
Yes.
How are you
Well, so so how are people going to be able to work on the same document at the same time? So we envision that a supervisor, for example, would be able to browse, say, all the section level components of a document, and then assign, say, 10 sections to 10 different people to proofread, for example, right? So the content management service then checks out those individual sections to those people. Each of those 10 employees gets a notification that, here's your work assignment, open it up, complete this task, submit it, and it gets updated in MarkLogic. So XPath queries into MarkLogic collections will allow us to take out pieces of XML at whatever component level we choose. So, yes, please.
So earlier you showed sort of your ETL pipeline. How is all that managed today? Right, everything before the database. How are you managing those services? What are they?
Do you mean like the legacy file-based process or the system we're building?
It looked like it was part of your, yeah, it looked like it's part of your current system. It's
This,
One back.
this.
Yeah, so like, all those services in the upper right-hand corner, how do you manage those, and what exactly are they?
So,
What do?
yeah, so these are REST services. They run on a web server. They run on an IIS web server. This is code written in C#. We use Azure DevOps for source control, right? So all of our source code lives in DevOps. We're using DevOps to deploy code to dev, test, and prod servers. So DevOps is used to manage our source code. It's used to manage the project itself. You know, all of our sprints are in there, all of our defects are in there, and then we use DevOps pipelines for code deployment.
So how many different recipes do you have, and are you finding yourself building 2 a month, or is it 2 a year? What is that?
Well, I mean, we're in active development for this thing, and we envision, I mean, many of them. We envision dozens of them, right? Because we will constantly be adding new publications to this system, and we really needed an approach like this to avoid writing specialized code on a per document basis, And so, the key to making this work is using multi-part data in the request and in the response. The recipe is able to pass parameters. We developed an XML representation of a file, right? So, you can define what's passed into a service. You can define what arguments are passed into a service in the XML, say the name of a transform, the name of a style, and then the service executes the instructions in the recipe. And so far it's working quite well. This modular approach really allows us to put things into production before every last thing is done, right? So, before we got a lot of this working, we were doing like the US code because that relied on the transform piece. It relied on the XBP piece. It didn't need the MarkLogic piece because it was a one-time thing, right? So, we're working our way through this huge collection of documents we need to modernize, and we're proceeding in the order of how much work do we have to do before we can finish something, right? Now, by the time we get all the way through this whole thing, we'll have the most difficult document of all in production, which would be the Congressional record, because it contains the most varied content, and it's huge, and it's published daily. The thing's over 1,000 pages often, and we get content up until 9 o'clock at night or later, and if they're up there reading Dr. Seuss books and there's a filibuster, it all goes in the record, right? So it's just politics, right? And we don't take sides. We faithfully print what's happening. So, well, thank you very much, everyone. This has been fun. I'll be around here today and tomorrow.